This was in a meeting. So theory exam 13-15 July. Yeah, I have no issues. 13 and 15. If everybody is okay for MSc, then I'll fix it. Is it fine for everyone? 13 and
Yes, sir.
Yes, sir.
13 is theory, right? Yeah.
Yes, sir. 13 theory and 15 lab.
It's 15 lab. Okay.
Sir, what is going to be the pattern of the lab exam? The entire lab exam of 100 marks. Internal
No,
we are
it will be
having.
internal only, 40 marks only.
Yes, sir. And then in the SEM?
SEM it will be 60 marks.
60 marks lab exam.
60 marks lab exam. It will have same pattern like Viva, uploading record, and doing, I think, 1 or 2 programs.
So, sir, Viva, uploading record and doing programs. Okay,
Yeah,
sir.
yeah. I think I showed you a pattern, right, last time?
Yes, sir, lab record you have shown.
Yeah. Not record, I mean the question itself, like similar one.
Yes, sir.
Yes, sir.
So you first will be filling the details, then you have to upload your record. Then there will be 2 questions. You have to complete the questions and upload them in a specified format where you have to write the aim of the program and the steps or procedure for the program and the source code and the output. So that is going to be the pattern. And so let me recap.
And sir, Viva would be of how much marks?
We'll skip it 20-20. 20 you will do one program, 20 will have a Viva for internal.
Okay, sir. Sir, we are going to have Viva in internals also.
It's you can take that as a model exam maybe.
Sir, we can have it on model exam, sir, for internal.
No, model exam you want to have extra then. That will be more, right? So let's keep it one. That is internal. It can be called as model exam also. I think last week we had internal for MTech and C++. So it took a long time for Viva basically. So any suggestions you want to tell?
No, sir. Actually, sir, I'm not getting it. Like, what are we going to have for internals? Viva and the lab writing programs both.
One program and Viva. That's it. Let's keep it like 20 marks, and then so it is internal is for 40 marks, right?
Yes.
So I'm keeping it as 20-20. So it will be like 20 marks for Viva and 20 marks for one program. This is internal.
Okay.
And in practical, I think I will keep maybe 2 programs.
So can't we have the Viva on the main exam date so that we will get some more time to study for the Viva?
Okay, I don't have any problem if you want.
Yes, sir.
Then
make it that way.
Then I will keep 2 programs in internal.
Yes, sir, you can do
2
that.
programs compulsory, and maybe time limit is 1 hour.
Yes, sir, that will work.
Okay, no issues. Then what about MTech? You are okay with the same pattern?
Sir, 2 question content 20 marks or 40 marks?
20-20. 40.
Okay, then Viva for only 5 marks.
Yeah. She asked we can have Viva last.
Yes, sir, that will be fine. Thank you, sir.
Thank you, sir.
Yeah. For MTech, it's the same
what
pattern.
What will be the portions for the internal 2? Actually,
internal 2, so far, whatever we covered, is it okay? First, I think we had only first unit, right? 1 second.
Yes, sir.
Go up. So file handling packages, applets, AWT. BioJava, I'm still trying to explore because It's not a well-maintained, documented one. That is the problem. I got
The AW2 is for both theory and internal, right? Or is it this?
theory and internal. I'm not getting.
So the internal theory we'll be having on 9th and lab will be having on 10th. So both of them will be having the same syllabus.
You are
right?
from MTech. Okay.
Yes, sir.
Yeah. Yeah, lab, we didn't have any exam, right? So it will be a basic only, whatever classes, objects, all those polymorphism.
Okay, sir.
I think you may be not surprised. You had last week C++, right? Almost same.
Yes, sir. We are okay with the pattern.
Yeah, then okay, no problem. Yeah. Because it's separate. So yours will be on 9th, right? Okay.
So theory on 9th and lab on 10th.
Yeah, right.
No, sir, it's lab on 9th and theory on 10th.
Yeah. He said lab theory actually, so together.
Yeah, sir. No, sir.
Yeah, no issues.
Thank you, sir.
I think all of you have submitted the assignment for Java. I believe so. If you have not yet submitted, please submit. Let me check once. Anybody has not yet submitted? I think MTech all have submitted and MSc 56. Anybody is missing? Total is 40 MSc have submitted and I think all are submitted, right? Then it's fine. Make sure you keep your record copy ready for the final exam. Any dates have been announced?
For what, sir?
Exam?
Yes, sir. Schedule is there. For Java, we have kept a common date for MSc and MTech.
Okay. Theory you're telling?
Theory and lab both, sir.
Okay. No issues. Okay, let's go into the class. Today's class will continue with threading and we'll see some more research slides today. I just saw some concepts. We'll see today. Same. I'll just share my screen. Can you see my screen?
Yes, sir.
Yes, sir.
Yeah. This is more research slides basically. Okay, I have to start recording 1 second. I guess it will start in a while. Okay, let's see what we saw last class. Let me maybe share the entire one so that I don't have to switch. Okay, 1 second, where we left. Okay. We saw about multi-threading in Java, like what are the threads and what are the functions basically in multi-threading is available inside the thread class, like start, run. And we saw some example what will happen if we directly initialize the run class or if we use the start class basically. So we'll see the same example here where we will look at some concepts again as a revision we can tell. So what is a thread? You can tell it's a program as various parts and which can run simultaneously. And there are two things like multitasking versus multi-threading. Multitasking is like doing different tasks at the same time. Like a task can be like 2 different programs or 2 different classes running separately. Threading in a sense, it's like simultaneously you are in parallel, you are running something or you are trying to execute something. And single threader and multi-threader is like usually our general normal programs are single threader. We don't use the concept of multi-threading until we explicitly mention. But when you go for any server side things, you can, some softwares you will be mentioning thread equal to this much thread it can utilize, like thread equal to 4 or thread equal to 12. So depending on your computation power, you can mention how many threads your program should consume. So that can be mentioned explicitly to the program so that it will use the maximum capacity of your computation power. And again, these are the advantage, like why we are using multi-threading to use maximum capacity of your computation power existing. And thread states we saw as the life cycle of threads, like when it is runnable, running, sleeping, resuming, and terminated. And we saw one more class which is scheduling threads. Thread priorities, like which is normal priority, maximum priority, and minimum priority. So another concept is like synchronization, where we will be looking at aspect how we can synchronize two threads to run simultaneously. And these are the thread class methods which we saw: get name to get name, and get priority or set priority to set the priority. And disallay will tell you that it is running or not. Join will wait for the thread to complete and then join along with the following threads. Run will initiate the start, and then we will, like run will directly run, but start if you use, it will initiate the run. Sleep is to delay the thread. So a simple example of a thread, same example, like we are creating a thread object T, and it just prints what is the thread basically. And we can see the name of the thread. So t.getName will give you the thread name. And here we are changing the name to my thread. So usually when we saw what is the thread name, will be like thread 0, thread 1, thread 2, like that. But you can set any name. It can be your name, or you want to define some process name. Say thread 1 is calculating this value, and thread 2 is calculating the average, 1 is calculating the sum. So that way we can set each thread names specifically based on the objective of the thread. And this is thread object, right? And this one is general statement. So as we saw previously, that a normal program is also doing a single thread process, you can tell. So here the normal one statement which is telling now in the main thread basically. So this is my initiated thread based object one, that is my thread, and the normal one is this one, like general statement. Now in main thread, we are just telling the current thread is T, and it will just print me my thread actually here instead of thread 0 here. And current thread seen from get name. So what is the name it will show. And this is for like just we are keeping it inside a exception handler, where we are telling run this thread for 5 times. I think 6 times it will run, 0 to 5. Then we are having a delay of 1000 milliseconds. And we can, like, if you want to print an exception, you can give any value, any statements inside that. So these are the important key points or functions which are used in the program. And output will be like, it will show first what we are clicking it, like here we are saying the main thread. So first here the print statement plus T, the thread name is thread main 5,5, that is a thread name. And current thread seen from the get name function. So you give get name, so it is called main thread basically. So it is showing main. And the print statement now in the main thread. And here current thread is what is the thread name, and seen from the get name function. Now the name is changed basically. So if you use t.getName, how it is showing, or if you are just using T, the thread directly, what is it is showing. That's the thing, nothing extra here. And this will print, or this will display the t.getName function here with 1000 milliseconds delay. So here it should be like thread and then plus n in the sense like it is printing the number. So n here is 0 plus n 0, 1, 2, 3, 4, 5. So it runs for 6 times. So simple thread example program here. Any questions, any doubts here? Which we saw in the earlier class, the same concept of how we can create a thread and use the thread set name for the thread. So two ways from the same previous class we saw it can be implemented from the runnable interface or by using the thread class. Using the thread class is the easy way, which we can just use or create a thread object, and then we can use the run method and start method to initiate the thread. Oops, sorry. And runnable is an interface where we have to create an object and then use thread and runnable thread object, and then what is the thread name, then we have to start. So if you use the thread class, it is direct, easy way. If you want to use the runnable interface, you have to follow this method to initialize or start the thread. So this is using the runnable interface basically. So here we are implementing this runnable one, and then we are just creating a function, and which will again in turn call another function, and it just prints inside the thread. And our main one is called class thread runnable demo. Here it's our main object, which is thread job, which is from the runnable class, runnable interface. And from the thread class, we are having a my thread, and which should hold the runnable object basically. So here it is my new thread, and the thread object, thread job is the object basically. So that is being used here to initialize this my thread object. So if you give my thread dot start, it will go to the thread, and then it will initialize the thread basically. I think I did an example of this one. Let me check. I have it. Alright. What is the class name? My runnable. Let me check. I have or not. Yeah, I have. But where's the program? That's just it. Let me try how this class runs. Let me have to compile it out of there. Let's see. Applications. Where is the program I should find first? This is the class file. Maybe I just renamed it separately, I think so. That's why I'm not able to find the correct name. Okay. I think this is. Yeah, correct. The class name is wrong. I was looking at this class name, but basically I have to use the main class name here. What it is showing is like, it is showing this step here back to main thread, and then it is printing inside the thread. So here what we did is we just override the existing method, which is run method. By default, it's present inside this runnable interface. So we just overrode that method. So that's why it is just printing inside that. If I run again, let's see what happens. Yeah, same. It will showing the back to main thread and then inside the thread class. I mean, just the print statement. We are not doing anything extra. It is just showing us just the print statements. If you want, we can initialize some condition, and then we want to do simultaneously printing steps. That way we can create by creating multiple thread objects. Another one we saw, which is called extending thread. Same directly you can create, which we saw in the previous examples, where we just created thread t equal to a new of thread. Otherwise, you can extend the thread class the same way, like how we are using the inheritance method or inheritance in groups. So when you inherit a class, what happens? You have all the features, all the members, and all the methods inside your class. So we are just overriding the run method in the thread class. Where is my cursor? 1 second. I'll use this one. So we are able to override that run method, and then what we are doing is like we are just creating a loop which will print 10 times that I am here, and then it prints exit from A. So like this is the loop statement that it will show I am here 10 times. Once this is done, it will show exited from A, and this is class A. So class A extends thread. So, and we are overriding this run method, and this is another class which is class B. And the same here also what we are doing is like creating a for loop. We just give dot so to the present. Same thing here, and then it will show I am there. And once this loop is done, it will show exit from B. And for the C, same. It is like I am nowhere, it will show, and then it will have exit from C. And this is our main class, which is called multithread, just to show how these individual threads work. And public static void main string args is the usual statements. And here what we are doing is we are running a loop, which will be, I think, running for 4 times, 0 to 3. And what it will do, it will start A, B, C. So if you know, right, if you call this way new with new, it will just instantly create that class object. So we are just creating an object, and then using the start method, which is by default present in all of the thread class. So A, B, C we are starting, and then we have a print statement, which is what is the count and what is the iteration count. That's what it will show. And if you see the output, it will be like print a multi-thread from nowhere, I think. Yeah, where it is printing. Okay. I don't have any print statement here, but let's assume that a print statement is here. Okay, it is printing I am here, so which is from the A, and it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Yeah, 10 times, and then it is showing exited from A. And based on this tab, it is just showing us a space. There is nothing extra or fancy here. And this is from another thread, and this is from the last thread, basically. So it is showing exited from C, and here it is again showing going I am there. So since we ran it multiple times here, if you look, we are running it for 4 times. But just printing which iteration is over, the last, basically. That is not shown in the output, but that's how it works. Same way we can also create directly using the thread object instead of doing this way. But what is the advantage of extending a thread class is like you can have multiple classes with multiple runs mentioned inside each of the class, and creating each object for each of the classes will give you a separate object with all the features from the thread class, so that you can say when you call or when you start one thread, that thread will perform one operation, the second thread will perform simultaneously another operation. But when you want to start or like when one thread is running, you want to initialize another thread, you can put one thread to sleep and then start another thread simultaneously. That way you can do that. That is the next step we'll see. This is the one like we will check. We can check is the thread alive or not alive in the sense it is running or it is over basically. So this will give you a boolean value which is true or false. And join we saw last class, which will wait for the previous thread to complete and then it continues. And it can throw an interrupted exception based on which thread it is following. And thread 1, thr1, thr2 are thread objects. So you can like use this way directly with the thread object, or you can use an integer which is a millisecond wait time to join with the previous thread when it is completed. So here is another example which shows you demonstration of thread. Let's see how this one works. So we are using the Runnable interface, and what we are doing is string name we are declaring and a thread object. So members of new thread basically, and new thread is our constructor. You can tell what it will do. It will take the string name, basically string thread name it will take, and it assigns the thread name to the name of this class, and it takes that name to this thread object also basically. So this here refers to this object. Name is the name of this one, like I mean which name we are creating the thread with this constructor. New thread, if you have to parse any name of the thread basically, then only it will initialize that name to the thread inside this class. And we are printing new thread is t is a thread object, right? So t.getName will display you the name, and this constructor is also starting the thread. T.start. Start is for starting the thread. And here what we are doing, we want to redefine or change something inside the run method. So we are using an exception, try. Why we are always using exception in this case? Because if you are working with threads, one thread can interrupt or merge with another thread. So that's why we want to have exceptions everywhere, so that if any exception happens, it will display what is the exception. Like whatever you want, it will display basically. But if you print E, it will show the exception which has been caught by this catch method. Sorry. So in this run method, what we are doing is we are having an iteration of 6 times, and then what we are doing is we are just printing the name of the thread in iteration. What is the iteration count? Like 0th iteration or 2nd iteration, like that, and then we are putting that thread to sleep. So thread.sleep, I think here it should not be thread.sleep. I think it should be this.sleep or the thread name.sleep basically. So here thread.sleep will generally put whatever thread is being called, because this is run, right? So run will be called basically using any thread object dot run. So that thread will be slept or kept on hold for 1000 milliseconds. And inside the exception, what we have is what is the name of thread and which is interrupted, and it will just in the next one it will just print the name, and then it will show us exiting out of this thread exception. That is the thing. You are any doubts so far here in this slide? Any questions? Any doubts here? If not, I'll just move to the next one. So here, this is our main method. The main class is join demo. So we are just demonstrating the join function by creating various threads basically. So thread thr1, 2, 3 are our objects. And as we saw, right, we can use this constructor, new thread, What we are doing is like we are creating this thread objects for our new thread class, which extends the runnable class. So it has all the thread features. Why? Because we have the thread object also, that is T. And 123 is a name, and thr123 are the thread objects basically. And thread 1 is alive, and we are checking is it alive or not by using the method is alive. It will just give you a boolean, right? So true or false, that's right. And what we are doing is we are just using a exception to tell that thr1 is our thread object from this new thread class, and T is our original thread dot join. Will join when that thread is completed. If not, it will, let's see what exception it is throwing. What exception it should throw is like thread 1 is alive, then again we are telling if there is an exception, we will print something whichever we want. And after this one, we are checking using this function. After it is run, we are checking is alive or not using that is alive function. So what happens in the first phase? You can see thread 1, new thread, because here we are giving the name basically here, which is getting initialized. So new thread, and then thread name 1, 2, and 1 in iteration 0. So then again it just started actually. So basically there are some interruptions happening in between. Why? Because we did not give any sleep, so it is all running simultaneously based on like its own priority basically. So if you notice, new thread 1 is from this here, new thread, and then the name 1 is printing, and t dot start is given, right? So it gets started automatically. The new thread 2, and this is our thread name 1, 2, 3 are thread names, right? So 1 in iteration 0. Then in the simultaneously, now the third one is getting executed. New thread 3. Then the second is entering the 0th iteration. Then it is saying, printing that thread 1 is alive. Same as like simultaneously all 3 are running. 3 in iteration 0. So these 3 are the initial iterations which has started, but at gaps. If you notice, thread 2 is alive, true, and 3 is alive, true. Then 1, 2, 3, 1, 2, 3. Like now they are like all simultaneously running all the loops here. It is running all the loops present inside this one. 1, 2, 3, 1, 2, 3, 1, 2, 3. And then here, if you notice 1, 3, 2, it just changes the order only. And 1 exiting. Here we gave thread sleep 1000, right? So that's why there is a delay here. 1 exiting, 2, instead of 2, like there 3 got first, 3 exiting, and 2 is exiting. And after this, everything is over. Now we are checking the condition at last, right? So, sorry. So this line basically, it is showing false, false, false because all of them got executed. If it is running, it will show it is true. If it's not running, it will show as false. Any question? You can try this thread, like creating multiple thread operation, and see how these threads behave. That you can practice as one example for maybe this week. And I'll just check out how we can like use biochar. It has a lot of functions, but still there is the documentation is not very clear for biochar. And the same concept of priorities. Here, set priority and get priority are the two functions. So our method is clicker, and we have 3 variables here for this class. One is long data type, which is click equal to 0, and our thread object T, and a private boolean which is running, which is true We are setting it by default. Okay. And we have a constructor also. It takes an integer input. What it does, it creates for this one, it creates the thread object, and it is setting the priority, whatever priority which we are giving, the number basically. And another method is there, which is get priority. It will return us whatever the number which is set to that thread. And it is of return type, which is integer type, so that's why it is int get priority. Or else you will have void. So public void run is our method which we are overriding. So while running is true, right? We set already true, right? It will initiate it will increment click. Okay, until this is true. This running step is true. And void stop is another method which makes the running to be false. And start is there, which will just start the thread, t.start. So here there is three variables and 1, 2, 3, 4, 5 methods. Okay. Is it clear, this one? Just we are creating different methods and then overriding also the existing methods. So existing methods are run and start. Start usually runs, but we are just giving start should start with the thread object. One thing what we are doing is we are setting the priority by getting a number. So this is our main class, which is thread priority. Current thread is one function where we can identify or give the thread value. So what we are doing is current thread. For the current thread, set the priority as maximum basically. Thread at maximum priority. So two clicker objects. One is high and the other is low. So both are having normal priority. Okay. And we are starting each of the threads. Threads in the sense each of the methods object basically which is being initiated with the clicker object. And thread.sleep for 10 milliseconds. We want to delay 10 milliseconds and then interruption. This is our exception, which will just print whatever we can keep any print statement or output. And we are initializing stop. What this stop will do is stop will change that run to false, right? Here. So then it becomes it becomes false so that the loop gets stopped basically. So another thing is once this is done, then it should start. That's why we are using a join method and including an exception for that. So here we are creating a print statement which is counter on low priority thread, that is low.click, and priority, what is the priority? We are just getting printed it. Nothing else here we are doing. So we can see how this one will run is basically for low priority thread. This is the clicker actually. And our priority is normal priority, so it is saying 5. But you can notice that this has run more times the high priority because we set current priority for this main class. Current thread.set priority is thread maximum, so we can observe that max priority has run more times here. This is how much? 33,99,000. One is 33,50,000. And if you run it second time, you can see it has run 33,000. There is no much difference here between two here also. But one constant observation is the low priority thread has run lesser times than the high priority threads. So priorities can be observed this way, showing that these threads are run multiple times in between the simultaneous time of the other thread, which is both are set at normal priority, but the priorities are shown like with the clicker we can identify only based on that. Otherwise, if we generally run, you cannot observe what is the priority is doing for each of the threads. I think we saw last time I set both to medium and something like that. What someone is messaging. We have class. Okay, no problem. I'll just stop here. Let me check. Yeah, this is basically the extension of the same program where we are setting the limit I and I plus 5. We are checking for each of the. I'll stop in 2 minutes. Okay. Just this is what we are doing is since we set int p right for the clicker object, what we are doing is we are using a loop instead of that, and then we are just setting the priorities from I plus 5, and then one is just the iteration value. And there also you can observe the changes. It has run like at different times. Since that for each iteration the I value changes, right? So I plus 5. So first one is set at 1 priority, another one is set at 6 priority. So what is the change or what is the difference in their priority level, which is shown in this output actually. And synchronization, which we'll see in the next class. I'll stop here. We can continue in the next class. I think Thursday. Yeah. Any questions, any doubts? If you have, you can ask.